In example 7, we have three terms, the 3x squared, the 24xy, and the 15x squared y. We want to factor the greatest common factor out of each term. Well, 3 and 24 and 15, just look at the coefficients first. All of those are multiples of 3. So I can factor out a 3 from each term. And then there's an x squared here, an xy there, and an x squared y. I can get an x out of each term. I can't get an x squared out of each term because even though there's an x squared in the first term and an x squared in the last term, there's only a single x there. So I can only get a single x in my when I'm factoring out the greatest common factor. And I can't factor out anything else. There's a y here and a y here, but there's no y in this first term, so I can't factor out a y. So now let's see what we're left with. When I factor a 3x out of this first term, 3x squared, that just leaves me with an x. And when I take a 3x out of the 24xy, well, taking the 3 out of the 24 leaves me with an 8. So I'll say plus, don't forget your plus sign right there. So it's plus 8. And then when I take, look at the variables now, when I take the x out of this xy, that just leaves me with a y. And you can check this as you go. You should be able to see that if we start distributing this 3x times x, that gives me the 3x squared, and the 3x times the 8y, that does in fact give me 3 times 8 is 24, and the x times the y is right there, the xy. So this is correct. And then we do our last term here. Don't forget your plus sign. Then when we take the 3 out of the 15, that leaves us with 5. And when we divide the x out of the x squared y, that leaves us with xy. And we're done. We've broken our original expression up into factors. Now this factor seems really big, but that's okay. It's at least simpler than what we were working with before. And that's one of the things factoring does. It breaks your expression down into simpler factors, which often end up being easier to work with.